All right. So last week we were looking at, or you were given some example to try on the receipt program. We are going to look at it again, and then also try out some we look at that again and then try out some few modifications we can do to that particular code. We're supposed to have some group assignments. That was last week. Also, because of some few challenges, the A class couldn't have it. So what happened was that we had to call it off. Okay, but hopefully next meeting, we are going to have them in the groups. All right, so our last online meeting, we looked at the input and output. That's the code that has to do with the printing out the receipt. So today we want to focus on the control structures. We look at control structures and then arrays. Control structures and then arrays. With the control structures, this is a topic that we were introduced to last semester. Okay, so as much as possible, I wouldn't spend much time on it unless you have some questions to ask. So the control structures, like we know from last semester, are there to control the flow of data in our programs, to control the flow of data in our program. Or what, to look at it, we want to write the program to tell if a condition will be executed or not. Or you want to write a program to prompt, or you want to write a program to determine how many times a particular statement or block of code, okay, should repeat itself. Okay. So basically, that's what the control structures does. And we saw from last semester that we have two types of control structures. That's the conditional or the branching control structures, sorry, and also the loops or the iterative control structures, okay, which helps in repeating certain parts of the code. So with the loops, sorry, with the conditional control structures, we're saying here that there is the if-else, okay, control, or there is the if-else statement. There's statement that deals with only if. There's also the, how do we call it? The switch case, okay, the switch case as well, which are also used to handle a condition when a particular case satisfies that condition. Okay. So it says here that with the if-else statement, it said you will often find yourself writing code that would want to execute some of the time, but not at all times. So for example, if you are writing a game playing program, you might want to print out a message each time the user achieves a new score and store that score. And you can accomplish that by putting the required line into the if statement. So I think we looked at this last week or last 2 weeks. So if, for instance, when you're playing a game, there's always a maximum score. Okay, so if it is the first time you are playing that game, whatever score you are able to make is considered as the maximum score. Okay, now if you play it for the second time, you are expected to exceed that maximum score. Okay, so the program is written in such a way that if the current score exceeds or is greater than the maximum score, then it should print out what? You have a new score. Okay. Then the maximum score will now be equated, or the current score will now be assigned to the maximum score. Okay. That's if the current score exceeds the maximum score. Okay. So that is how the if statement works. Okay, so you have the syntax comes just like we saw in C++ last semester. You have your if condition, the if keyword here. Then you specify the condition for which the statement should either be true or false. Then if it is true, it executes the statement within the curly brackets. Now, the if condition can run for a number of statements. Okay, so you can have more than one statement in there with a condition running. And then we also have the if-else condition. So if the test, which is a condition, is true, in this case, it's going to execute the statement within this curly bracket. Okay. However, if this condition or this test is false, it skips to the else to execute whatever statement is inside your else, whatever statement is given as the else. Now, there's also the nested if-else statements. So it says here that this sequential structure is appropriate if you want to execute any combination of 3 statements. Okay. Any combination of 3 statements. So for example, you might write this code in a program for a questionnaire with 3 optional parts. Okay. Any combination of which might be applicable for a given person. So you have 3 different conditions or 3 different test cases, okay, for which the application should execute or should be executed. So if the first condition is met, it will handle or it will execute the statement in the first condition. Okay. Now, note, in this case, there's nothing like else if. Okay, so if that condition is met to handle it, then comes quickly to the next one, execute it, and then comes to the next statement, and then it will test it as well. So in this case, it's going to perform the if for all the 3 conditions. So whether this statement is true or false, okay, whether this condition here is true or false, it will still come and check for the next condition, okay, and also check for this condition as well. Okay. Now, let me just give you a typical example. I think it's a question I brought last year or last 2 years in the exam, so that we can look at how that question was handled. Just a moment. All right, so please, can you all see my screen?
Yes, sir.
Yes, sir.
Yes, sir.
Right. So this was a question. Now, we're supposed to indicate which if else or which nested if else is appropriate for each of these conditions. I hope you can all see the conditions. Okay, so 5 different scenarios have been given. Okay, so we are going to look at how if else or the nested if else can be handled for each of these conditions. Okay, so what I'll do is I'll take the first one. Let me take the last one, which is more straightforward. And then let's switch to the whiteboard. So the last condition is saying here that, or the last scenario is saying here that we are looking at what a student, whether a student passed an exams or failed an exams. Okay, so these are the 2 scenarios, whether a student passed or failed. Okay, now, a student passing or failing an exams is based on what? The score the students made, okay, or the exam score. That's what will determine whether a student passed or failed, okay? So we come up with an assumption that if that student's score is greater or equal to 50, then we say that what? That student passed. Okay. So in order to determine which if else nested if else statement to work for this, is quite straightforward. Okay, so we say if the condition or the test case, that's exam score is greater than or equal to 50, then we say what? Student let me just use the s.out, system.out, and say student passed. Else. Now the else doesn't have to take any condition. So else you S out student failed. Please, I hope you are all here.
Yes, sir.
I think I would have to type this instead. So the nested if statement, if else statement, which will satisfy this particular scenario, is a straightforward if else. Okay. So if the condition is met, we'll say that what? Print out student passed, else print out what? Student failed. Okay, so this particular example or scenario is a straightforward one. Yes, what's the issue with the whiteboard? I said Boating. You said the whiteboard is not helping. Okay, so let me just erase it and then go over it again. Please, can anyone see what I've written on the whiteboard?
Yes, sir. Sir, don't mind them. Some of them are colorblind. Don't mind them.
Yes, sir.
I'm just giving a scenario. I'm using the S out. I'm not writing it in full.
Yes, sir.
Okay, so just to show you how it will. We are printing. We already know what the print line and the print does. Okay, but the main concern here is whether a student passed or failed. How to use the if else. Okay, and the nested if else statement. So in this particular scenario, it is straightforward. Either a student passed or a student failed. Okay, which is a straightforward scenario. Now let's look at the next example. The next one is saying that I'm starting from the bottom, okay, using the bottom up approach. So the next question is saying that we should compute a grade. Compute a grade of A, B, C, D, or F based on a percentage. Okay, based on a percentage. So let's assume that you've written exams and you are supposed to gain or be awarded this grade after your exams. Okay, so how are you going to compute something like this? You have A, B, C, D, okay, to F. Okay. So let's say that if someone is getting A or is making A, that person say had 80%. If someone is making B, let's say 70, let's assume that C so let's assume A is 80, B is 70, C is when someone makes 60, D is 50, and then F is less than 50. Okay, so above 70, above 80, all the way to F, okay, being below 50. So with a scenario like this, okay, how are we going to handle it? This is one condition. Above 70 is another condition. 60 and above, another condition. D. Okay, so you can tell that what we have we have 5 different conditions here. So how do we use the nested loop to accomplish this? Okay. So to use the nested loop to accomplish this, we say that for the first scenario, if A, okay, or let's say if the percentage, okay, if the percentage is greater than 80, right? Are we all with me?
Yes, sir.
Yes, sir.
If percentage is greater than 80,
Yes, sir.
we are saying that what? We should S out as system.out. Okay. We should print out grade is A. That's the first scenario. Okay. Now, if this condition is not met for the percentage, then the next condition will be what? B. Okay. So for the B part, we are going to say else if the percentage score, okay, so I'll just copy this, come down and paste. If the percentage score, else if percentage score is greater than 70, it should print out what? B. Okay. That means if this condition is false, it should come and execute B. Then it goes on again to do for grade C, which is if the percentage score is from 60 to 69, that's greater than 60, then it should print out grade C. Then the next one is saying that if it's greater than 50, it should print out, let's say greater or equal to 50. Let me use greater or equal to for all of them. This should be a D. Okay. Now, the final one is going to be else, because that is the last condition, okay, which is being given. Okay. The last condition there is the F. So we've done A, we've done B, we've done C, we've done D. Then it says or, take note, it's saying or F. It didn't say and F, saying or F. Okay, so the or F means that else, the last one should be else. The last one should be F. So if the last one is F, we are going to put else. Now, with anytime you use only the else, you don't add a condition to it. The else is just saying that, okay, none of these conditions stated earlier is satisfied. So the else should now come, or the else should be the last thing that will be executed. So we have else grade is F. Okay. So the else here, like I'm saying, means that none of your values for A, B, and C, and also D, okay, were satisfied. Okay, so if none of them were satisfied, then it should give you F as your final grade. Why? Because we are saying that what A or B or C or F. Okay, that means that if you run this program, it's going to print out only one grade. Please, are you all following?
Yes, sir.
Yes, sir.
This code or this scenario here is saying that the code should print out only one grade, and the grade should be A or B or C or D or F. Okay, so if you are going to print only one grade, then we have to go by the option first, starting with the if, then else if for the next condition, else if, and then the final condition will be else if. Okay, so in this particular example or this question, what I'm expecting you to give us the answer for computing this is if followed by an else if, followed by another else if. How many else if? 3 of them.
3.
Yes. And another else if. And then finally, an else. Are you following?
Yes, sir.
Yes, also Prince, your hand is up.
Yes, sir.
Yes, sir. Good evening, sir.
Yes.
Sir, please, about your question, so what if the or is supposed to be n? If the or is end, is it going to be else or?
If the or is n, what do you think?
I think it's going to be else if again or.
So this is what it means. Read it this way, okay?
Okay.
Compute a program and compute a grade of A and B and C and D and F based on a percentage. Okay, so what it's trying to say is that when you use the or, it's either it will print for one of them, but if you use the and, what it means is that it's going to print for all of them once they meet the condition. Okay, so in that case, we'll eliminate the else. Now, if we eliminate the else, okay, and we do if throughout, so this will also be if percentage is let's say less than 50. if percentage is less than 50. Okay, so this is what will happen. It will first come and check for the percentage. So let's say someone had a percentage of say someone had 55%. Okay, that 55%, it will check with this particular case. Okay, if it is true, it will print out A, because what, 55% is bigger than or is greater than 80. Okay, so in this case, it will give you A. Then it will print out again. Sorry, it will come and check for the if condition here again. If this is greater than 70, okay, and yes, because it's an if, it's going to what? Check for this again and print out B. Then it will check for that of the C grade, okay, and 55, oh, sorry, it's rather less, okay, 55 is rather less than 80, okay, so this will be false, it won't print for this, sorry. Then it comes to check whether 55% is greater than or equal to 70, which is also false. Okay. Then checks for this, which is also false. Okay. Then it will check for 70, whether it's greater than 50, which is what? D. Okay. Then it will also come and check for this scenario, whether it's less than this, which is also false. Okay, so in this case, it will print for only the D. Are we all here?
Sir, please. Sorry to interrupt you.
Yeah.
Sir, but with the all two, it's like it will only print one of the options. It's either A or B or C or D.
Exactly. Exactly.
By the end to it will also print one option.
Not necessarily in all the cases. Okay, not in all the cases. So this is because based on the conditions we've assumed here, we are working with the conditions we've assumed here. Okay, so it will test based on the condition. But in this case, we are not using the else. We are just doing if. Are you following?
Yes, sir.
So our percentage value is 55. And if you look through all the 55, it's only this that satisfies that condition.
Yes, sir.
Okay.
Yes, sir.
It's only this that satisfies the condition. Now, let's say our percentage value is now 85. Okay, 85%. Now look at what will happen if you are going with 85. If you go with 85, it will check for the first if. If 85 is greater than or equal to 80, and that is true. Okay, so if it is true, it will print what? A, because 85 is greater than or equal to 80. Then it will come to another if. If 85 is greater than or equal to 70, that is also true. So it's going to print B. Okay. Then it comes to the next one. If 85 is greater than or equal to 60, that is also true. So it will print C. Then it comes to the next one. If 85 is greater than or equal to 50, which is also true. So it's going to print D. Now the last condition is if 85 is less than 50, that is false. Okay, so it won't print out. Okay, so this is false. The last one will be false. So what is happening here is that with the value of 85, it's going to print out A, it will print out B, it will print C, and it will print D.
Okay, sir.
Okay. However, if we have left it as if, else if, once it checks the first condition and the 85 is greater than 80 and it prints A, because the rest are else if means that what? The condition, the preceding condition should have been false for it to execute the next condition. Okay, but the first condition happens to be true. So with the else if, it's not going to handle the other conditions. But if you are going to use the if throughout without the else, what happens is that it will check for all the conditions, whether they are true or false. It will continue to check for all of them. Okay, so the best way to approach a scenario like this with the emphasis on the or here is by using the if, else if. Are you with me?
Yes, sir.
Yeah. Felix.
Okay,
Felix,
thank you,
your
sir.
hand is up. Yeah. Felix Zankwa, your hand is up.
Yes.
Hello, Felix. Okay. So that's it for the second scenario. Okay. So let's look at the third one. So the third one is suggesting that and that's one interesting scenario here, which is saying that a number, you want to check whether a number is divisible by 2, 3, and or 5. Okay, a number is divisible by 2, 3, and or 5. Okay, so take note here, there's an and here. Can we all see it? Are we all here? Okay, so in this particular scenario, first, we want to know if a number is divisible by 2, what is the condition? If a number is divisible by 3, what is the condition? If a number is divisible by 5, what is the condition? Okay, so who can help us with the first one? If a number is divisible by 3, how do you check whether a number is divisible by 2? How do you check? Anyone? Yes, Felix, your hand is up.
So, okay, if a number is divisible by 2, when you use the modulo operator, when the operation is executed, the result is supposed to be 0.
Okay, so if we have,
let's say 10.
Let's assume the variable is number.
Okay.
Okay, so let me type it so that people can see what I'm typing. Okay, so if a number is divisible by 2, we are saying that's what?
So when you use the modulo operator,
So the number mode, right?
yes, sir.
Mode what? 2.
Mode 2 will
Should
give
be
you
equal to 0.
0. Yes,
Okay,
sir.
that means that what? When we do that, it's not going to give us a remainder.
Yes, sir.
Okay, so that's the first scenario. Now for the next scenario, if a number is divisible by 3, if a number is divisible by 3, let me use a different color. Okay, it's the same color. If a number is divisible by 3, who can help us? Edward.
Okay, thank you. So with that, with the same modulo, to be equal to 1.
With the same modulo, it should be equal to 1.
Yes,
So
modulo
1
3
mode,
equal to 1. Yeah.
1 mode 3.
Yes.
Sorry, number mode 3.
Yes, equal to 1.
Are you sure?
No, sorry, 2 equal to 1. 2 equal to 1, sorry.
Are you sure? You agree with him? If a number is divisible by 3.
No,
Okay,
3.
Marvelous is saying something. When 3 mode 0, when any number mode 3 is equal to 0. You agree with that of Marvelous?
Yes, sir.
The one saying yes, sir. Which one do you agree?
Said normal mode 0. Normal mode 3 equal to 0.
So what did you say? Number what?
Number mode 3 equal to
Number
0.
mode 3.
Number mode 3
Equal to 0.
equal to 0. Okay.
Yes,
So any number mode 3 equal to 0. That means if you divide the number by 3, if a number is divisible by 3, okay, there should be no remainder. That doesn't give you a remainder. Then we say that what? That number is divisible by 3. Okay, and then the last one is what? Number mode what? 5. Are we all here?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
So these are the 3 scenarios. Now, given these 3 scenarios, how are you going to implement them? Okay. So if you look at it carefully, it's saying that what? And or. Okay. That means that we want to check whether a number is divisible by 3. Okay. And that same number is divisible by 2. And that same number is what? Divisible by 5. Okay. So
the last one, there is a mistake. He said if a number is divisible by 3 instead of 5.
Oh, sorry. Thanks for that correction. All right. Okay. So over here, we say that if now we specify the condition. So who can tell us how we write the condition? Anyone? Yes, Bill, is your hand still up?
No, sir.
Prince, Asari.
Right. Number less equal to 2.
Less
Equal to 2.
less than equal to 2.
Less than equal to 2.
Hey, are you sure? Are you sure? Who wants to try? Okay, Samuel. Samuel, is it Blepo?
Sorry, actually, I had a code. That was why. Can I continue?
Actually, Ben.
Yes, who is speaking? Prince.
Yeah, say
Yes.
equal to 2 signs, 2 equal signs, 0.
This, no, start again.
Greater than equal to 2. Greater than equal to 2. That's right. Yeah. Then at the back of 2, equal to 2 signs, 0.
Equal to 0.
Another another equal to should be 2.
Wow. Interesting. So what is this greater than equal to here? Prince. This is a comparison operator. And you can't use 2 comparisons operators in this case. This is to say that number is greater than or equal to 2.
So use the modulo sign in between the number and the 2.
So what's the modulo sign?
The one with like percentage sign.
Percentage, okay.
Yeah.
Yes, someone has typed that in the chat. Okay. And then what? If the answer is equal to 0. Okay. So this is the first condition. So if this condition is met, then we should execute the statement and say S out or system.print out what number is divisible by 2. Okay. Now, so for the next one, are we going to use else if, or we are going to use just if, and why? For the next condition, are we going to use else if or just if? Yes, Edward. Edward.
Hello? Okay, hello. Sorry. So I was saying that it depends. If we want to nest, I mean, the structure, we could use if, but if we decide not to nest it, we could use else if. Then the last condition, we take the else.
So reading the scenario we have here, how do we go about it? Reading the scenario.
Okay, so we can use else if for both the remaining conditions.
You are saying we can use what? Else if.
Else if, yes, for both remaining conditions.
Okay, so let me use else if. And then you explain to us what would be our output if we use else if. You said what? The last should be what?
The same else if.
Else if. Okay.
Yes.
This one is divisible by 5. Divisible by 3. Then divisible by 5. Is that all?
The else, the last condition, the else, we can put any message we want. Can put try again.
Try again.
Sure.
If at first is not succeed. Try again. All right. So, Edward.
Yes, yes.
Can you explain this code to us and what our output will be? Pick any number at all and tell us what the output will be.
Okay, so so for instance, if you are creating a program to determine whether 3 is an odd number. So the first condition, the user can type any number, but so if written a condition to determine the odd number when the user types 3, or for instance, if we give 3 numbers, 2, 3, 5, and we want the user to type 3. Sorry, hello?
Yes.
To determine whether 3 is an odd number, the first condition states that if the user enters 2, and then
So
we will
give us a number. You give us a number.
Okay, let's say 6.
So our number is
6.
Our number is 6.
Yes.
Okay. So anywhere we see number,
yes, we put 6 there.
6 there.
Yes.
Okay.
Good. So number 6, when you divide number 6 with the modulo of number 6, you get an even number. So obviously the first condition will print out, which is number is divisible by 2. And yes, so after printing the first one, the code will end. But in case the number is not 6 and it is let's say 7, and it is 3.
So if it is 6,
if it is 6, the first condition will print out.
The
number is divisible by 2.
And then it will print out what? Number is divisible by 2.
By 2. And then
it will end, or it will
looking
continue.
at condition 2 to.
Will it end there or it will continue?
It will end, sorry. It will end because
it won't end. Okay.
Yes, you can divide 3 by 6 too. Okay, so 6 is not an ideal number.
Are you
so
sure?
it will, so yes, so the second condition too will run, and then hey, did I write the correct code? Let me check.
Daniel Dome.
Yeah.
You want to help?
Yes.
Okay, first and foremost, do you agree that this is how we are going to handle the scenario using the if else?
No, sir, please no.
Pardon?
Sir, please no.
No.
Yes.
So how do we handle it?
The question said whether a number is divisible by 2, 3, and 5. So that means if we are supposed to find for the if we are supposed to know the number, we are not supposed to bring the else, because it's not saying that the number should be divisible by only just one number. It's saying the number should be divisible by 3 numbers. So if we are supposed to do this one, it's supposed to be, if into bracket number is divisible by 2, it should be equal to 0. Then it will S out number is divisible by 2. Then when we come to the next one, there should not, like, we are not supposed to bring the else. We are just supposed to write if into bracket number is divisible by 3. So that means if the first one satisfies it, then it will print out number is divisible by 2. If the second one too is also satisfied, it will print it out. Then the third one too, like that. But maybe if the number given is satisfied by only the first and the second, then that means the third one it won't print out.
Okay, so you are saying that what we should go away with what? The else. Is that what you are saying? We should do away with the else.
Yes.
Okay. So with the number 6. Okay, with the number 6, how do we execute? Or let's use a different number. Let's say a number. Sorry. Let's work with a different number. So let's say our number is 30. Okay, so Daniel, we are using the number 30. So everywhere we see number, we put 30 there.
Yes.
So what will be the output of our program?
So for the first one, is the 2 can be divided, 30 can be divided by 2, which is 50. So it will print out number is divisible by 2.
Okay. So that means that 30 is divisible by 2.
Yes.
Okay.
And the second one, 30 can be divided by 3. So that means it will print out number is divisible by 3.
Okay.
Yes. And the third one too, 30 can be divided by 5. So it will print out number is divisible by 5.
Okay. So in this case, the number 30 is divisible by 2, 3, and or 5.
Yes.
Okay. Now, if you decide to use the else, this is what will happen. Okay. If you decide to go with the else, what will happen is that it will first check if 30 is divisible by 2. Okay. If 30 mod 2 is equal to 0, and this is true, it will print out number is divisible by 2. But because of the else, it won't run the remaining part of the code. Okay, the remaining part of the code won't execute. Are we all following?
Yes, sir.
Okay, because we are saying
Yes,
that was else. Else means that this condition, the first one, number being divisible by 2, should be false for it to now check if the number is divisible by 3. Okay, but because number is divisible by 2 is true, then it won't execute the remaining conditions. Okay, so this particular scenario, instead of using the else, the if and the else if, all you do is to use if for all the 3 conditions to tell whether the number you've entered is divisible by the 3 numbers given. Okay, so that is how you approach a scenario like this. Yes, Sam, Augustine Jr. Your hand is up.
Sir. Sir,
Yes.
please, I want to clarify something about what we are discussing right now.
Yes.
The question is whether a number is divisible by 2, 3, and /or 5.
Mm-hmm.
So let me put a statement. Maybe Kofi is a or and boy. So it's like we have a/and boy. So I'm supposed to pick from any of the letters, right?
Wait. Let's first judge the statement you are making, whether it's applicable.
Okay.
Okay. So can you make the statement again? Kofi is what?
So Kofi is a/and boy.
A plus and boy.
// and boy.
Kofi is a / and boy.
Yes.
So why are you making that statement?
So I want to, you see, from this statement, I have
Mhm.
a / and. I have a / and boy. So I'm supposed to either a or and for my statement. I'm to decide which of the letters I will use, right?
This particular statement, I don't know, the question you're asking that hasn't applied to what we are looking at.
From our question, it is either
From your question,
whether
it doesn't
no,
apply.
from what you have here, it is either I decide to use and or I decide to use or because there is slash there. From this, it's either I decide to use the and or I decide to use the or am I supposed to run a code for both of them?
Okay, so this is a scenario. We are being given a number. Now, that number should be divisible by 2, or it should be divisible by 3, or it should be divisible by 5. At the same time, that number can be divisible, okay, or that number is divisible by all the 3 numbers that is given, 2, 3, 5. Okay, so this is a question that is looking at taking it from the worst case scenario. We are looking at what? The number being divisible by 2, 3, and 5. Okay, the number being divisible by 2, 3, and then 5. Okay, now someone is placing another form of nested loop in there, but what we are looking at is that if the number is divisible by 30, we say that what the number is divisible by 2. Okay, you should print out the number is divisible by 2. If the number is divisible by 3, it should print out the number is divisible by 3. If it's divisible by 5, it should print out the number is divisible by 5. Okay, now you can handle this in a case where you are looking at the number being divisible by all the conditions that you've been given, or it's being divisible by only 2 of them, or maybe only 1. Okay, so if you want to handle this question by using the else, just the else, using the if, what will happen is that it will only identify 1, value. Instead of identifying 1 or 2 or 3 being divisible by 2, 3, and 5, what will happen is that it will end up just identifying either it's divisible by only 2, only 3, or only 5. Okay, so you have to write the code in such a way that even if the number is, let's say, 25, 25 is not divisible by 2. Okay, so it should still check for 25 not being divisible by 2, and also check for 25 being divisible by 3 or not, and also check for it being divisible by 5. Do you get it? I hope you are getting the scenario.
Yes, sir.
Rather than using the else if will limit it to just you wanting one answer, whether it's divisible by 2, or is divisible by 3, or is divisible by 5. Okay, but when you use the if throughout, it makes it's going to check all the conditions and decide which ones are true and which ones are false.
Okay.
Tamimu. Is it Tamimu? Abdul Baki Tamimu.
Yes, sir. Hello, sir.
Yes.
Please, please, can you hear me, sir?
Yeah, I can hear you.
Yeah. Okay. Please, if I understand you, I'm saying by using if in the for the code throughout, it's going to
I can barely hear you. I mean, your voice, it's loud and then all of a sudden it faints. Can you speak up louder?
Okay. I said, if I may understand you well, you are saying with this code, if you should use the if, it's going to answer for both and or. For the question, 2, 3, and or 5.
Yes. Right. Yes.
Okay. Thank you, sir.
Okay. All right, let's take the last question from Evergreen. And let's go back to our handouts. Yes.
Sir. Okay, sir, I think we get your explanation, but depending on the question that the other guy asked, I think we want to know whether when we are given such question, okay, like whether a number is divisible by 2, 3, and or 5, whether we should use the and or the or. But because when we use whether a number is divisible by 2 and 3 and 5, that's when we will run the code as you are saying. But if we are using whether a number is divisible by 2 or 3 or 5, that's when we will use if, then else, if, then else, if, then else. So I think that's what they wanted to ask.
But that has been explained. That's what Tamimu just mentioned. So I'm saying that if you use the ifs throughout, it handles both scenario. in this case.
Okay, so it handles the end.
It handles both scenarios in this case.
Okay.
So it's not
okay,
like you have to write two separate programs. One is doing it for and one is doing it for all. In this scenario, if you use the if, it's going to handle both scenarios, whether the number is 2, is divisible by 2 or 3. Okay, now this question, what will happen is that someone is giving then some people are typing in the chats the scenarios. So they are saying 2 or 3 or 5. And then what? 2 and 3 and 5. Those are not the only combinations you can get in this question. You can also get 2 and 3 or 5. You can get 2 or 3 and 5. Okay, so these are all possible combinations you can get from the code. So if you are trying to follow the code by this possible combination, then you'll be writing about 5 different codes. If that's the angle you want to handle it, you'll be writing 5 different codes for each of these combinations. Okay, but what I'm saying is that if you use the if, it's going to capture all this combination into one, where you don't need to write the code for it being and or it being or. Okay, the example you gave about Kofi, Kofi is a, or an. It's just 2 scenarios, a or and. But in this case, it's giving you what? 3. Okay, 2, 3, and or 5. Okay, so if you use the else, if you use the if throughout, it captures all the various components, okay, all the various scenarios which you are trying to get from the response. I hope that is clear.
Yes, sir.
Okay. I thought of bringing in this particular scenario because it is necessary we understand that particular concept when it comes to programming, where there are times you have to use if, okay, inside the program, and scenarios where you have to use the if, else, if, and even sometimes nest them, like we have seen in this case. All right, so we'll look at this code when we meet face to face. This code is looking at implementing the body mass index for 2 individuals. And then compare them. So the code uses the scanner for input and returns and the parameters that is going to return. So we use a scanner console, new scanner. So enter the BMI for the first person, enter for the second person. Then whatever response that was is printed out, and then we find the difference. So we look at this code when we meet face to face and tell whether the person has is underweight, normal weight, or obese. All right, then there's also the switch case approach. Okay, the switch case. Okay. So with the switch case, you indicate a switch. Okay. Now for each switch, there should be a case. If the case satisfies the expression inside your switch, then it will execute that statement. So for instance, in this particular example, it's saying that scanner equals new scanner, okay, and then it has declared employee's number. Okay. So the employee number first we have the employee name, the hourly salary, the time, okay, weekly time, regular time, overtime, regular pay, overpay, and next pay. Okay. Now, we are prompting the user to enter the employee's number. Okay. Now, when the number is entered, the number or the digits entered has to be 5 digits. Okay. So if the digit entered is the same as 82500, then that employee's name is given here. If the employee's digit is 82501, then it is this. If the employee's number is given as case 82502, then this is the employee's name. Okay. Now, if the number doesn't follow any of these 3 formats or any of these 3 cases here, then we say what? That will be a default value. So the employee name is unknown. Yes, I hope you are following that scenario.
Yes, sir.
Okay. So usually the main difference between the switch case and the if-else statement is that with the switch case, especially if you are working with numbers and strings, and the values you are working with are explicit values. Okay, the values you are working with are explicit values, or are clearly given, are clearly or are precise values. Then it is best you use the switch case. Okay, so for instance, your index number is a value that is explicit. It's not like we want to find a range of people within a particular index number. Okay, it's explicit. So if we want you, for instance, Herbert Annan, we want someone with the index number of 01221351D. Okay, that number is explicit. So in such a scenario, a switch case is best to handle those particular problems. Okay. Now, if let's say we have 2 or 3 people with the same, with 2 or 3 people whose index numbers we want to identify, we can also use the switch case to handle that. Okay, if you go to C++ from last semester, there was one example there that used that particular approach. Okay. So this is how that's how we use the switch case as well. Any question with the switch case?
Please, sir, can you go over again?
So I'm saying that with the switch case, okay, the case is taking values that are explicit, that are precise, that are clearly communicated, okay, inside the program. Okay. So once the value is explicit, you use the switch case to handle those cases. For instance, if I say, okay, enter the index number, and I enter your index number, so student's index number, and the index number is 0201221582D. Okay, if I put that as a switch case, as a case here, it compares whatever value or expression is in the switch to whatever case is here. And once it corresponds to it, to what executes the code within that particular case and then break. Okay, so if that index number is 0201221582D, then we are saying what that student is Maxwell Anoche. Okay, because what Maxwell's index number or student's ID is explicitly given. So we are using that as a case. So once it corresponds with the switch, the expression in the switch, then it executes that particular case. Okay. If not, it goes to the next case to see if that is what was entered. Okay. Any question? So one difference between the switch case and the else is that, like I mentioned earlier, the if else statement is executed based on the condition inside the if else statement. Okay, but with the switch case, the switch statement executes per a user, okay, or per case. Okay, it executes per case, and that case should be explicitly given, or it should be clearly defined. And also with the if-else statement, you can have use it for multiple statements, okay, for multiple decisions, okay. But with the switch case, you have a single statement for a number of decisions. And the switch case, you can choose between multiple options and so on. Okay. All right, so let's move to the loops. Now we know loops to execute tasks while the condition is met. So it says here that in programming often involves specifying redundant tasks. So the for loop helps to avoid such redundancy by repeatedly executing a sequence of statements over a particular range of values. So suppose you want to write out the square of the first 5 integers. Okay, this is how you go about it. Okay, or this is how we would have approached finding what? The square of the first 5 integers. So we say, okay, 1 concatenates. So 1 squared is equal to 1 times 1. 2 squared is equal to 2 times 2, which is 4. 3 squared is equal to 3 times 3, which is 9. 4 squared is equal to 4 times 4, which is 16. 5 squared is equal to 5 times 5, which is 15. Okay, now imagine we have to do this for the first 15 numbers. That means you are going to repeat this all the way to what? 50 squared is equal to 50 times 50. You are going to have over 50 lines of code. And that is what this particular statement is talking about. Okay, that this loops helps to avoid redundancy, okay, inside your program, where you can just by 2 or 3 lines write a program to execute a statement. Okay, for the first 50 numbers or first 50 integers. Okay, rather than writing system.out 50 times and finding the square of those numbers. Okay, so this is the output we will get. But at the same time, that is not the best approach to handling a scenario like this. Okay, rather you use the loops to repeat the statements. All you need to do is just specify this condition in there, and then the loop will repeat it for you as many times as you want it to be repeated. Okay. So if a number is starting from 1 all the way to 5, the first 5 numbers, I just look for a variable, say I, a variable I to represent numbers and specify the conditions. Okay, so if I start from 1, I should end at, say, I greater than, or sorry, I less than or equal to 5. Okay, so anywhere I see a number, all I put there is I. Then I will handle, or the variable I will handle all those conditions. Okay, so this is the syntax. We've seen this from last semester. You have the initializer, the condition, or the continuation test, and then the update scenario. Okay. I have an image. I'll try and look for it and then probably share it with you on how this works. Okay. The flow of the loops. So it says here that we are finding the square. Okay. So using the for loop, instead of writing this number of times, okay, using the for loop, you just introduce it once and it handles it. So int I, like I said, everywhere we see the numbers, okay, we are going to put I there. So I is equal to 1. Okay, that's the initializer. That means we are starting the count from 1, or our first integer should be 1. Now this I, which is 1, if it is less than or equal to 5, okay, that means that for the continuous test, the condition should always be less than or equal to 5. Then we have what? The update or the increment. Okay. So if I is 1 and 1 is less than 5, then you are saying that I, which is 1 squared is equal to 1 times 1, which is 2. Which is 1. Okay. Now, after doing that, we come and update the value of I. So I plus plus, which will give us 2. Now, I being 2, 2 is still less than or equal to 5. So it comes back and print 2, which is our new value of I. 2 squared equals 2 times 2, which will give us 4. Okay, then this will repeat a number of times. So if we want the first 50 integers, all we do is, instead of writing this line of code 50 times, okay, instead of writing the system.out.println 50 times, all we do is we specify, change this condition here to I less than or equal to 50, so that this system.out will print the integer squared 50 times. Okay, I hope you're all here.
Yes, sir.
Yes, sir.
All right, so I think I found the file I was talking about. Let me share it so that, because it's in a form of a picture, sure you appreciate how that works. Just a moment. Having some difficulty sharing it. All right. I hope you can all see.
Yes, sir.
Yes, sir.
So it's saying
Yes,
that
sir.
with a for loop, when your program needs to keep doing some tasks for a specific number of times, you use the for loop. Okay, so let's look at how it works. So the for loop is saying that you have your for, the initialization, the condition, and then the update. Okay, so the initialization is 1. It will first start from there. After the initialization, it goes to check the condition. If that condition is true, now look at the arrow. If that condition is true, it will come and execute what you have inside your bracket. Okay, now after executing it, it will come all the way and update the value. That's where we see the plus plus. Okay, now after updating, it will come and check if the value that was updated satisfies the condition. If it satisfies the condition, the loop, that's if it is true, it continues again. Okay. However, if it is false, there's an arrow going up, which is if it is false. If it is false, automatically, okay, it exits the loop. So you come out of the loop. Okay, I'll share these images with you on the LMS. Now, then there's also so this is just talking about the syntax. When you get the handouts, you can read more into it. Okay. Then there's also the point where you have the minus minus. Okay, that's the decrement, to decrement the value. Now you can have nested loops. Nested loop means that you have a loop inside a loop. Okay, a for loop inside a for loop. Okay, now we'll be seeing this a lot when we start looking at arrays. Hopefully, I should introduce arrays next week, okay, because of time. So it says public class pyramid example, int I is equal to 1, I is less than or equal to 5, I plus plus. Okay, now what this is going to do is that it will first loop when I is 1. So when I is 1, it will come and handle J. Okay, so let me just copy this and let's move to the whiteboard. Clear everything here. Let me arrange the code quickly so that we can look at it. This, I hope you are following the way I'm indenting the code. So we have this code. Now this is how this program is going to be executed. You have values of I here. Okay. So let me just draw it like a table. And then you have values of J, okay, which is within the I. Okay. Now it's saying that when I is equal to 1, okay, and I, which is 1, is less than or equal to 5, we have what? I being 1, I is less than or equal to 5. What will happen is that it will come and execute this for loop, which is the J loop. Okay, finish executing the J loop for when I is 1 before it will come and update the I. Okay, so when I is 1, it's saying here that J is also equal to 1. Okay, now if j is equal to 1, j, okay, so we have j also equal to 1. Okay, now j should be less than or equal to I. J should be less than or equal to I. Now, is j less than or equal to I? J is 1, I is also 1. So j is equal to I. So this condition here is true. If it is true, it says it should print out what? An asterisk. Okay, so the asterisk has been printed out. Now it will come and update the j. So j is 1, 1 plus 1 will give us 2. Now j is 2, but 2 is not less than or equal to I, which is 1. Okay, it's not less than or equal to I, which is 1. So it will go back into the I loop and then update the I value to 2. So our I now become 2. 2 is less than or equal to 5. Yes, that is true. Our new value for I, our I is still starting from 1. So if j is 2, if I is 2, our j is starting from 1. So j being 1, 1 is less than or equal to I, where our I now is given as 2. Okay, our I value is given as 2. So we are going to get j being 1. So if j is 1, it will execute or print out 1 star. Then it will update the j. So 1 plus 1, which will give the value of j to be 2. So if j is 2, 2 is less than or equal to 2, where our new value of I is 2. So if j is 2, 2 is less than or equal to 2. That condition is true. So if it is true, it will print another star. Okay, then it will update the j again. So 2 plus 1, which is 3. Now 3 is not less than or equal to I. Our I now is 2. Okay, 3 is not less than or equal to 2. So it will exit the j loop and then go back to the I loop and update our I. Now from 2, if we add 1 to it, our I will now become 3. 3 is less than or equal to 5. Then it comes back to the j loop and then starts from j being equal to 1 again. Sorry. And start from j being equal to 1 again. So if j is equal to 1, 1 is less than 3. Okay, so it will print 1 asterisk, then update the j from 1 to 2. 2 is also less than 3. So it will print another asterisk. Update the j again to 3. Okay, that's the j plus plus. 3 is also greater than, 3 is less than or equal to 3, which is also true. So it prints this asterisk again. Okay, so you notice that the asterisk will be printed. So when it gets to 4, j will be 1, 2, 3, 4. That means we are going to print 4 asterisks. When it gets to 5, if I is 5, we said I should be less than or equal to 5. So if I is 5, we are going to get what? I being 5, the j would go from 3, 1, 2, 3, all the way to 5, because our j should be less than or equal to our I. So we print this star 5 times. Okay. Now when I is updated to 6, 6 is not less than 5, so it will automatically exit the loop. Exit the loop, and then we'll have our answer as this. Okay. So if you go back to the material, this is our output. Okay, this is our output. So that's how the nested loops work. Now, this nested loop will be very, very important. Okay, when we start practicing it, when we start introducing or looking at arrays. Okay, so we'll be using that a lot, the arrays. So I want you to spend time practicing the if-else statements and then the loops, especially the for loops. Okay, because we'll be using that in an array. There are some few examples here, okay, which I'd want you to look at. Okay. So if you want to find the sum of a sequence of numbers, okay, how to go about it. If you want to find the sum of a sequence of numbers and how to use user-specified numbers, okay, whether they are in the negative. So this one will tell whether the number entered has negatives or has no negatives, and also find the average. So someone enters 8 numbers. Some of the numbers are negative. It determines how many of them are negative numbers. Okay, so in this case, 2 out of the 8 numbers that were entered are negative. And then it finds the average. All right, so that is it. Any question? Any question? Any question? Any question? All right, so if there's no question, we'll end the class here for today. And then please, next week, like I said, there was supposed to be some assignments. Okay. Unfortunately, when the A class started,